So in the last lecture, we looked at some applications of the quadratic formula that I chose kind of carefully to make sure the discriminant, that's the part under the square root there, always came out positive, right? So we always ended up with real solutions. In this lecture, we're going to look at a couple of examples where that's not the case, right? And we'll see what happens when you get a negative value under that square root. So I've got an example for us to look at, and it's going to start off exactly the same way. We need to start by pulling values for a, b, and c from the equation. A is the number in front of the x squared. That's kind of an implicit 1. There's a 7 in front of the x, and the constant term at the end there is 16. All right, so now I'm going to drop those into the formula. We get negative 7 plus or minus square root of 7 squared minus 4 times 1 times 16, all divided by 2 times 1. Now, you do the arithmetic, get your calculator out if you absolutely have to, and we get negative 7 plus or minus square root of negative 15. There's that negative part. Divided by 2. So how do we handle that negative? Well, I'm going to split this up. Right? I'm going to make it negative 7 plus or minus the square root of negative 1 times the square root of 15 over 2. So I kind of explicitly pulled that out. And the square root of negative 1, that's our imaginary number. That's I. So if I put I there in place of the square root of negative 1, we get our final answer. Negative 7 plus or minus I times the square root of 15 divided by 2. And that's it. Right? 15. All you can do with that is 5 times 3. Neither of those is a perfect square. So nothing we can do to simplify that further. Okay, so how about this thing? 2/3 x squared plus 3x equals negative 6. Well, the first thing I have to do, remember, to use this formula, I got to set the equation equal to 0. Right? So, and that's easy enough. We'll just add 6 to both sides. Right? And that gives us 2/3 x squared plus 3x plus 6 is equal to 0. And yeah, what now? Well, I mean, there's that fraction. The formula doesn't care. Formula works for fractions. You could have square roots. You could have transcendental numbers like pi for the coefficients. Doesn't matter. You put them in the formula, it's going to give you the answer. The question is, how much work do you have to do to get there? I would just assume not work with that fraction. It would end up not being so bad in the 4ac part. But down there on the 2, there's nothing that's going to cancel, and it's just one more thing I got to worry about. It's not that I can't do it. It just adds one more layer to the question. So what I'm going to do is I'm going to multiply both sides of the equation by 3. Right, so if I distribute that into the parentheses, 3 times 2/3 is just 2. Fraction goes away, and the equation becomes 2x squared plus 9x plus 18 still equals 0. So now, I mean, the numbers are a little bigger. Right, and yeah, okay, that's maybe a thing, but I'll take slightly bigger numbers over the fractions as fielder's choice. So let's pull our numbers. A is 2, B is 9, C is 18. If I put those into our formula, it becomes x equals negative 9 plus or minus square root of 9 squared minus 4 times 2 times 18 all over 2 times 2. Now you go to your calculator. If 4 times 18, it's a little big. Go to your calculator. This becomes negative 9 plus or minus square root of negative 63 over 2. And I can split that negative 63 up 2 ways, actually, two parts. I'm going to make it negative 9 plus or minus square root of negative 1 times 9, because 9 is a perfect square, times 7 all over 4. And now I can get my final answer. The square root of the negative 1 becomes I. The square root of 9 becomes 3. And everything else stays the way it is. So x equals negative 9 plus or minus 3i square root of 7 all over 4. Not the prettiest number in the world. All right, but sometimes that's how these things work out. Okay, so looking ahead. This, for now, wraps up our discussion of solving polynomial equations. We're going to circle back to it in a little bit later on here in a later chapter. Next chapter, we're going to continue our discussion of these quadratic functions, because they're particularly useful in their own right. They describe a lot of different things, and they're also simple enough that we can break them down and analyze a whole bunch of their properties in really convenient ways.